means myself, Anasha, Assistant Professor at L3 Institutes of Engineering and Technology. So today we are going to discuss few more topics of sequence and series. So let us begin with its first topic, D'Alembert's ratio test. So if un is a positive term series and limit n tends to infinity un plus 1 upon un is equals to L, then for L less than 1 the series converges. For L greater than 1 the series diverges. And for L is equal to 1 the test fails. That is, we have to apply some other test, right? So firstly you have to find the limit n tends to infinity un plus 1 upon un and find the value of L. And if L is less than 1, then you can write it as a convergent series. Greater than 1, then the series is divergent. And if L is 1, then we have to apply some other test. Okay? So when this test is applied, the series that involves factorials or other products including a constant raised to a power n, for example 3 raised to n, right? Then often we are using ratio test. Okay? So in two types of notation, one is factorial and one is constant raised to a power n. We will always use ratio test. Okay? So let us begin with its examples. So the example is, test the convergence of the series summation n is equal to 1 to infinity 2 raised to n upon n factorial. So here un is equals to 2 raised to n upon n factorial. We need to find un plus 1. So replace n by what? N plus 1. So you will get what? 2n plus 1 upon n plus 1 factorial. Now we have to find limit n tends to infinity un plus 1 upon un. So put the value of un plus 1, that is 2n plus 1 upon n plus 1 factorial. Now put the value of un, that is 2n upon n factorial. Now rearrange the terms. So you will get limit n tends to infinity 2 times n factorial upon n plus 1 factorial, because this can be simplified as 2 raised to n into 2. Okay. Now we can write n plus 1 factorial as n factorial into n plus 1. Now these two get cancelled out. So now finally solve the limit, right? So as limit n tends to infinity, this will go to 0, which is less than 1. Okay. So L less than 1. So we can say that by ratio test, the given series is convergent, right? Now let us start solving one more example. Is the series summation n is equal to 1 to infinity n raised to n upon n factorial convergent? So here you are given un as n raised to n upon n factorial. Now find un plus 1 by replacing n by what? N plus 1. So you will get n plus 1 raised to n plus 1 upon n plus 1 factorial, right? So you can simplify this as n plus 1 raised to n into n plus 1, right? Upon, this can be simplified as n factorial into n plus 1. So these two gets cancelled out. So finally what remains? N plus 1 raised to n upon n factorial. Now let us find L, that is equals to limit n tends to infinity un plus 1 upon un. Now put the value of un plus 1, that is n plus 1 whole raised to n upon n factorial, and put the value of un, that is n raised to n upon n factorial. Now these two gets cancelled out. Now you can take out what common? N common. So what will get out common? N raised to n into what will remain? 1 plus 1 upon n whole raised to n. Denominator will remain as it is, that is n raised to n. Now again these two gets cancelled out. So what is remaining? Limit n tends to infinity 1 plus 1 upon n whole raised to n. Okay. Now this limit, we know the answer, that is equal to e, which is greater than 1. So by ratio test, what we can say, that the series is divergent. Okay. Next, let us solve one more example. here we have to test the convergence of the series summation n is equal to 1 to infinity 2 raised to n upon n cube plus 1. So here your un is 2 raised to n upon n cube plus 1. So finally un plus 1 will be equals to 2 raised to n plus 1 upon n plus 1 whole cube plus 1. Right? We have replaced n by what? N plus 1. Next, let us find the limit, that is L is equals to limit n tends to infinity un plus 1 upon un. Put the values of un plus 1 and un. Now next, we will rearrange the terms. So finally what we will get, limit n tends to infinity 2n plus 1 into n cube plus 1 and upon 2n into n plus 1 whole cube plus 1. Now let us simplify this. So on simplifying you will get limit n tends to infinity 2n into 2. Take out n cube common. So you will get n cube into 1 plus 1 upon n cube. Similarly in the denominator 2 take out n cube common. So you will get 2 raised to n into n cube into 1 plus 1 upon n cube whole cube plus 1 upon n cube. Now this gets cancelled out, n cube also gets cancelled out. So what is remaining? Limit n tends to infinity 2 times 1 plus 1 upon n cube upon 1 plus 1 upon n cube whole cube plus 1 upon n cube. Now we know the limit n tends to infinity 1 upon n, that will go to 0. So finally what will remain? Only 2, that is greater than 1. Therefore, by ratio test, we can say that our given series is what? Divergent, right? Next, the test is Raabes test. So, whenever ratio test fails for factorial or a constant term raised to a power n, we have to use Raabes test, right? So, if we are given a positive term series un and limit n tends to infinity n times un upon un plus 1 minus 1 is equals to L, then the series converges for L greater than 1. The series diverges for L less than 1. And this test also fails for L is equals to 1. That is, we have to apply some other test. Okay. So, whenever the ratio test fails, we have to apply which test? Raabes test. Okay. So, now let us find the convergence of the series summation n is equal to 1 to infinity 4 raised to n into n factorial upon 2n factorial. So, let us start with its solution. So, firstly, we will apply ratio test, right? So, let us start applying ratio test. So, here your un is 4 raised to n into n factorial upon 2n factorial. Now, let us find our un plus 1. So, it will be equals to 4 raised to n plus 1 into n plus 1 factorial into n plus 1 factorial upon this will become 2n plus 2 factorial, right? Now let us find the limit, that is n tends to infinity un plus 1 upon un. Put the values of un plus 1 and your un. Now let us simplify this. So on simplifying you will get this will be replaced by 4 raised to n into 4. We can write n plus 1 factorial as n factorial into n plus 1. Similarly, this can be written as n factorial into n plus 1. This will go in the numerator. So, here will come 2n factorial. Next, this can be written as 2n factorial into 2n plus 1 into 2n plus 2. This will remain as it is 4 raised to n into n factorial into n factorial. So, what is getting cancelled out? These two will get cancelled out, n factorial will get cancelled out, 2n factorial will get cancelled out. So what is remaining finally? Limit n tends to infinity 4 into n plus 1 into n plus 1 into 2n plus 1 into 2n plus 2. Now again from this we can take out 2 common, right? And gets cancelled out with 4. So what will remain? Limit n tends to infinity 2 into n plus 1 upon 2n plus 1. Okay, now we will take out n common from the numerator and denominator. So we will get limit n tends to infinity 2n times 1 plus 1 upon n upon n times 2 plus 1 upon n. Again this limit will go to 0. So finally n gets cancelled out. So finally the answer of the limit will be equals to what? 2 upon 2. That will give us answer 1. So we can say that our ratio test fails. Thus we have to apply Raabes test. Okay. So start applying Raabes test. So for that we have to find un upon un plus 1 minus 1. Now we already have the answer of what? Un plus 1 upon un. Okay. So we will put that by taking the reciprocal. So you will get 2n plus 1 upon 2 times n plus 1 minus 1. Now we simplify this. So you will get 2n plus 1 cross multiply minus 2 upon 2 into n plus 1. Now these two gets cancelled out and what will remain? Minus 1 upon 2 into n plus 1. Now we have to find our limit, that is limit n tends to infinity n into un upon un plus 1 minus 1. So we will put the value of this, which is minus 1 upon 2 into n plus 1, right? Now take out n common from the denominator. So what will remain? Minus 1 upon 2n into 1 plus 1 upon n into n. Again this n gets cancelled out and this limit will go to 0. So what will remain finally? Minus 1 upon 2, which is less than 1. So what we can say from Raabes test, the series is divergent. Okay. So in today's session we have studied firstly what? Ratio test. In this we have to find L is equals to limit n tends to infinity un plus 1 upon un. Now the series un is convergent if L less than 1, divergent if L greater than 1, and the test fails when if L is equal to 1. Now whenever the test fails, right, we have to apply which test? Raabes test. Okay. So in this we have to find L is equals to limit n tends to infinity n times, take the reciprocally of this, un upon un plus 1 minus 1. Since we have taken the reciprocal, this will change, right? So the series un will be convergent when L greater than 1, divergent when L less than 1, and here too the test fails whenever L is equal to 1. So we have to apply ratio test or Raabes test whenever you see factorial notation or a constant raised to n, right? I hope you have understood throughout the session. Thank you for watching.